Series, bro, series. All right, I got you. We'll do a 14-part series on series. So first we'll explain what a series is and how it relates to a sequence. So a sequence is just an ordered list of numbers. That's it, 2, 4, 6, 8. That's a sequence. Now a series is just when you add a sequence together. So 2 plus 4 plus 6 plus 8. So a series is a sum of a sequence. Now when there are just a few terms or a finite number of terms, we call it a finite series. But if the pattern keeps going forever, then it's an infinite series. Stick around. Follow for more. Part 2 of the Series Bro series. Given the sequences 3, 6, 9, 12 and 2, 6, 18, 54, explain which is arithmetic and which is geometric and why. So the first one, 6 minus 3 equals 3, 9 minus 6 equals 3, 12 minus 9 equals 3. So we're adding the same amount each time. And that's why it's arithmetic. And then the second one, 6 divided by 2 equals 3, 18 divided by 6 equals 3, 54 divided by 18 equals 3. Here we're multiplying by the same number each time, so it's geometric. So arithmetic means add by a constant, geometric means multiply by a constant. Follow for more. This person named Add asked for help with series, so let's help him out. Part 3. Write a formula for the nth term of an arithmetic sequence. In part 1, we talked about what an arithmetic sequence is. Now let's find a formula to get any term in an arithmetic sequence. Let's look at our example. 3, 6, 9, 12, and so on. Each term goes up by 3. That's our common difference. D, our common difference, equals 3. Now the first term is 3. This one here. So a sub 1 equals 3. And that sub 1 there, that just means that's the number of the term. So the first term is 3. Now to get the second term, we add d once, and we get 6. To get the third term, we add d twice, and we get 9. So in general, we add d a total of n minus 1 times. Now what does that mean? Well, the third term, the 9 there, n is 3 because it's the third term. And we subtract 1 from that and we get 2. So we add d 2 times to get 9. So the formula is a sub n equals a sub 1 plus n minus 1 times d. Let's look at an example to explain that. A sub 5, so the fifth term, what's that equal? Well, before we made it up to the fourth term, we made it up to 12. Let's look at the fifth term. So we start with a sub 1, that's 3, remember? We add n minus 1. So that's 5, because we're looking at the fifth term, n is 5 here, minus 1 times d. And d, we said, is 3. Well, we just do some quick math here. 5 minus 1 is 4, times 3 is 12, plus 3 is 15. So the fifth term is 15. And that's how we can find any term without listing them all. I'm Chill Guy Does Math. Follow for more. We're chilling, we're doing math, we're helping people. Let's do this. So we're going to derive the formula for the sum of an arithmetic series using the write it forward and backward trick. So if you don't know what an arithmetic series is, check out the previous videos in this 14-part series. So let's look at the first 5 terms of a simple pattern. 3 plus 6 plus 9 plus 12 plus 15. Now we could continue with that and just keep going, but we're only going to be concerned with the first 5 right now. So we'll call that total S sub 5. That just means the sum of the first 5 terms equals 3 plus 6 plus 9 plus 12 plus 15. Now we can rewrite that backwards, and it's still true. I'm just rewriting it. plus 12 plus 9 plus 6 plus 3. It's the same thing. Now if we add those two things together, here's where it gets interesting. If we add them together, we just get 2 s sub 5. And let's see, 3 plus 15. 3 plus 15 plus 6 plus 12 plus, we're just adding them together, plus 12 plus 6 plus 15 plus 3. Okay, interesting. Now, each of those sums, if you notice, equals 18. Interesting. So, there are 5 terms, and each of them equals 18. So 2 s sub 5 equals 5 times 18. Make some room here. Interesting. Now we can divide both sides by 2, and we get s sub 5 equals 5 over 2 times 18. Aha. So now this works for any arithmetic series. We can generalize that. So in general, I'm running out of room here, but that's okay. S sub n equals n over 2 times a sub 1 plus a sub n. Cool. Anyway, I'm just a chill guy who does math. If you like this video, give it a like and follow. If you ever take an Algebra 2 or a college algebra class, you're probably going to need to know about series. So I'll break that down for you right now, make it nice and easy. We're going to find the sum of the first 20 terms of an arithmetic series. Now, in our previous video, part 4, check that out if you haven't seen it, we went over the formula to find the sum of an arithmetic series, and that's this. S sub n equals n over 2 times a sub 1 plus a sub n. Now here, the first term is 5, so a sub 1 equals 5. The difference per term is 3, so d equals 3. And we're finding the sum of the first 20 terms, so n equals 20. So first, we'll find the 20th term using the formula that we looked at in part 3 of this series, and that's a sub n equals a sub 1 plus n minus 1 times d. If we want to find the 20th term, we just plug that in. So a sub 1 is 5 plus, we're looking for the 20th term, so 20 minus 1, and we said d equals 3, so we multiply by 3 there. Simplify that, you get 62. So now we'll substitute that into the series formula, this one here, and we say s sub 20 equals 20 over 2, because n is 20, times a sub 1 is 5, plus a sub n is 62. We found that here, our 20th term. Now we just simplify. A sub 20 equals what? 10 times 67, which equals 670. If you enjoy this type of math, nice and calm and easy, give a like and a follow. Thanks. We're making it easy to learn about series, part 6. Check out the previous videos for more good stuff. So, let's say we have a sequence. 3, 6, 12, 24, 48, and so on. So each term is just the previous one times 2. So the second term, a sub 2 equals 3 times 2. That's 6, right? The third term, a sub 3 equals 3 times 2 squared. That's 12, right? 2 squared is 4 times 3 is 12. A sub 4 equals 3 times 2 cubed. That'll give you 24. So you see the pattern. Each time we add one more factor of r, and that gives us the general term, a sub n. So any term in this sequence, we could pick a sub 1 million if we wanted to. that equals a sub 1, which is just the first term, times r, and in this case, r equals 2. That's this number. That's the one that we're adding. We're multiplying more r's each time. All right, so times r to the n minus 1. So what does that mean? If we're looking at a sub 4, for example, the fourth term, that's 1, 2, 3, 1, 2, 3. So 24 is the fourth term. So the exponent for the fourth term is n minus 1. So 4 minus 1 is 3, and that's where that 3 comes from. I hope this is making sense. If not, post something in the comments. You can yell at me. So this works for any geometric sequence. For example, let's say we had a sub 1 equals 5 and r equals 1/2. Then the fifth term, a sub 5, equals, well, let's plug into the formula. A sub 1 is 5 times r is 1/2, and n minus 1, well, n is 5, so n minus 1 is 4. So that's how you find the nth term of a geometric sequence. If any of that didn't make sense, check out the previous videos in this series. Give a like, please, and follow for more. Math doesn't have to be stressful. In this 14-part series, we're talking about sequences and series after we got a request on that topic. Previous video, we talked about finding the general term of a geometric series. Now we'll talk about the sum formula. So let's say we have a sequence. A sub 1, a sub 1r, a sub 1r squared, all the way up to a sub 1r to the n minus 1. That's what we talked about in the previous video. So now let's take the sum of that. So s sub n, the sum of all that, equals a sub 1 plus a sub 1r plus a sub 1r squared. We're just adding what we just wrote, a sub 1r to the n minus 1. So now, if we actually multiply that by r, we get r times s sub n equals a sub 1r plus a sub 1r squared plus a sub 1r cubed plus all the way up to a sub 1r to the n. It's no longer to the n minus 1 because we multiplied everything by r. So now if we subtract, if we take s sub n minus r to the s sub n, or rather r times s sub n, we get, so if you notice, a sub 1r cancels with that a sub 1r. The r squared cancels with that r squared. R cubed will cancel out. And the a sub 1 r to the n minus 1 cancels out as well. So the only thing left is this one and this one. So what we get is a sub 1 minus a sub 1 times r to the n. So now if we factor this out, we take s sub n times 1 minus r equals a sub 1 times 1 minus r to the n. We just factored it, and now we divide both sides by 1 minus r. We get s sub n equals a sub 1 times 1 to the r, 1 minus r to the n over 1 minus r. So that is the formula for finding the sum of the first n terms of a geometric series. Okay. Hope that made sense. If not, please ask any questions you have in the comments. And remember to check out the previous videos in this 14-part series so it all makes sense to you. Like and follow and appreciate your support. Are you taking Algebra 2 or College Algebra? If so, you're probably going to need to know about series. In this 14-part series that I'm making here, I'm trying to make this concept easy for you. So follow along. In this one, we're going to go over finding the sum of a geometric series. So let's take a look at an example. 3 plus 6 plus 12 plus 24 plus 48. So first we'll identify what we know. The first term is 3, so a sub 1 equals 3. Now if that a sub 1 looks strange to you, check out the previous videos. I go over everything. Okay, now the common ratio is found by dividing each term by the one before it. So we'll take 6 divided by 3. The common ratio r equals 6 over 3, which equals 2. So now we use the formula for the sum of a geometric series. We derived that in the previous video. We say the sum of the first n terms equals a sub 1 times 1 minus r to the n all over 1 minus r. So now since there are 5 terms, we'll say n equals 5. So now we substitute everything in. S sub 5, which means the sum of the first 5 terms, equals a sub 1 is 3, 1 minus r is 2, and n is 5, all over 1 minus 2. And now I just simplify this. You could use a calculator or whatever you got to do. So let's see. 2 to the 5th is 32, so 1 minus 32 times 3 all over negative 1. Anyway, that works out to be 93. So yeah, I hope that was helpful. Check out the previous videos if you haven't seen them yet, and follow along for more. If you kept adding numbers together forever, could they ever equal one number? Does that make sense? With geometric series, that is possible. Let's take a look. Suppose we have the series 5 plus 2.5 plus 1.25. And that just keeps going forever. So notice that each term is half the one before it, so they get smaller and smaller. In this case, the common ratio r equals 1/2. And notice that the absolute value of r is less than 1. So when the ratio's absolute value is less than 1, then multiplying by r again and again makes each term shrink towards 0. Let's look at the sequence that corresponds to this. We have 5, so the sequence would start 5, and then 2.5 is 5 times 1/2. And then 1.25 is 5 times 1/2 squared, which equals 5 times 1/4. And the next term would be 5 times 1/2 cubed, which is 5 times 1/8. Now notice that the limit as n approaches infinity of 1/2 to the n equals 0. It's just getting smaller and smaller. It's getting closer and closer to 0. So suppose we start with the formula that we talked about in the last two videos, the finite geometric sum. S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Now, if none of this makes sense, check out the previous videos. I promise I explain everything clearly. So as n becomes very large, r to the n gets so close to 0 that its effect on the sum disappears. So as n approaches infinity, r to the n approaches 0. So the infinite sum formula for geometric series equals a sub 1 over 1 minus r. This r minus n just cancels out. It gets so close to 0 that it doesn't matter. So this is only valid when the absolute value of r is less than 1. If this was helpful, give a follow and a like, and check out the previous videos in this series. I appreciate your support. If you struggle with math, or if you enjoy calm math videos, stick around. We're doing a 14-part series on sequences and series by request. Previous video, we talked about the infinite sum of a geometric series. Now we'll just work through an example. Suppose we have 5 plus 2.5 plus 1.25 and so on. We know the first term is 5. and each term is half the one before it, so the common ratio equals 1/2. So since r in absolute value is less than 1, we know the series converges, and we can find its infinite sum. As we derived in the last video, the infinite sum equals a sub 1 over 1 minus r. We just plug in what we know, and that equals 5, which is a sub 1, over 1 minus r, which is 1/2. So that's 5 divided by 1/2, which equals 10. So the infinite sum of this series equals 10. Please like and follow. I appreciate your support. What the sigma is sigma notation? Okay, so we're going to take a deeper look at sigma notation, the shorthand for writing long sums neatly. So you might have seen something like this in your math career. If you haven't, you might see it someday. So we have the sigma notation, which means sum. And we have from I equals 1 to 4. So this means we start with I equals 1, and then we go I equals 2, and we keep going until I equals 4. So 1 plus 2 plus 3 plus 4. And that equals 10. So this equals 10. So the big Greek letter sigma means sum. The bottom number, the lower limit, tells you where to start. The top number, the upper limit, tells you where to stop. And the expression next to it, called the general term, shows what you're adding. So here's an example. Let's look at the sum from 1 to 4 of 2i. So that equals 2 plus 4 plus 6 plus 8, and that equals 20. So we're starting with 1 again, but since we're multiplying I by 2 every time, we count by 2's. Okay, so in general, you can write it like this. There's the sum notation from k equals 1 up to n of a sub k. So k is the index of the summation, 1 is the starting value, n is the ending value, and a sub k is the general term, the pattern for each term in the series. All right, I hope that was helpful. Oh yeah, and check out the rest of this 14-part series for more info on sequences and series. What can we do with sigma notation? Well, let's find out. This is part 12 of 14 of the series and sequence series. Let's say we have this sum from k equals 1 to n of a sub k plus b sub k. Well, what you can do is you can break it into two different sums, and that makes it easier to simplify. So we have the sum of a sub k and the sum of b sub k. B sub k. All right. Another property you can do, let's say you have this here. K equals 1 to n of a sub k minus b sub k. Well, I bet you can guess what this one is. It is the sum of k equals 1, a sub k minus k equals 1 to n of b sub k. So you can split them apart and subtract them as well. And the last thing we can do here, let's say we have a sum, k equals 1 to n of c times a sub k. Well, you can just pull out the constant, and that can become c times the sum of k equals 1 to n of a sub k. So those are our three properties. Follow along for more. Let's crack right into this one. We're going to find the sum from 1 to 4 of 2k plus 3 to the k. Previous video we learned how to break that up into two different sums. One of them will be arithmetic, the first one, and the second one will be geometric. Aren't you happy we're learning all these cool terms in this 14-part series? Okay, so remember the formula for the arithmetic sum equals k times a sub 1 plus a sub k. We learned that very early in this series. And then a sub 1 equals 2 times 1 here, which equals 2. And a sub 4 equals 2 times 4, which equals 8. Okay, so we just plug those into the formula. 2 plus 8 over 2. You could use your calculator and do what you got to do, and that's 20. Now for the geometric part. Let's remember that formula. S sub k equals a sub 1 times r to the k minus 1 over r minus 1. And here a sub 1 equals 3 to the 1, which just equals 3. And r equals 3. So we plug those in. S sub 4 equals 3 times 3 to the 4 minus 1 over 3 minus 1. Use your calculator, whatever. We get 120. So the final sum of this thing here equals 20 plus 120, which equals 140. Hey, if some of that didn't make sense, check out the previous videos in this series. I promise we keep them chill and interesting. Thanks for your support. All right, here's everything we covered. So a sequence is just a list of terms, 2, 4, 6, 8, and so on. A series is the sum of a sequence. And then we looked at two different types, arithmetic and geometric. Okay, so a arithmetic sequence looks like this. A plus D, A plus 2D, and so on. Geometric, A times R squared, and so on. Okay. So to find the nth term of an arithmetic series or a sequence, you use a sub n equals a sub 1 plus n minus 1 times d. For geometric, a sub n equals a sub 1 times r to the n minus 1. Now for the sums, s sub n equals n times a sub 1 plus a sub n all over 2. For geometric, s sub n equals a sub 1 times r to the n minus 1 over r minus 1. And then we looked at infinite geometric series. So that sum equals a sub 1 over 1 minus r when the absolute value of r is less than 1. And then finally we looked at some sigma properties. So let's say we have k equals 1 to n of a sub k plus b sub k. We can split that apart into two different sums, like so. B sub k, and that also works for subtraction, so we can do that. And then finally, we can pull out a constant. Say we have a constant c times a sub k. We can just pull that out in front, and we get k equals 1 to n of a sub k. All right, I hope this series was helpful for you. It was 14 parts. If you haven't seen the other videos, please go back, check out my channel, check out the full series, and show some love. Give me some likes, follows. I appreciate all of your support. Also, give me a comment on what you want to see next. I'm working on college algebra right now, and then I'm going to work my way up from there. All right, thank you for your support.